This is the prep packet video for Unit 4, Chapter 9.1, Objective Number 2. In this objective, we work to find higher roots. We started with the idea that if I had this, I was looking for the square root of a number. And there's nothing written here in the index spot when I'm looking for a square root because it's understood that I'm looking for the square root. If I want a higher root, they're going to write it up here in the index, right up there. So that means I'm looking for what number times itself 4 times will give me x. So let's try one here. Let's try, what's the fourth root of 81? I might know that off the top of my head, but I might also have to do a little work by factoring. So I know that 9 times 9 makes 81. So I could be looking for the fourth root of 9 squared. Getting close. Or I could be looking for the fourth root of 3 squared times 3 squared. Hey, wait, that's the fourth root of 3 to the fourth. I think I've got it. There it is right there. I got a match 4 and 4. So the fourth root of 81 would be 3. And again, it's an even index, so I'm looking for the principal root. It's the absolute value of 3 equals 3. What if I have another number and I'm not quite so sure? What if it's even just a square? How would I figure that out? If I'm looking at, let's see, what's the square root of 484? Well, again, I might do some factoring and figure out that 484 is 2 times 242, and 242 is 2 times 121, and 121 is 11 times 11. If I'm looking, now I'm looking for, let's say, 2 of a kind. 2 and 11, 2 and 11. That means that the square root of 484 is 2 times 11, or 22. That's the principal root. You would do the same thing to find a higher root, working to find primes. And I have to tell you that you won't always be able to find an even perfect square. If I asked you to find the square root of something like 630, well, that's not going to work because it's not a perfect square. Again, when you start to factor, you're looking for multiples. You're looking, here I need 4 of a kind, here I have 4 of a kind. As I do the problems, I'll show you this a little better. So here it says to find each root if possible. And again, I have this from another video, but I want you to keep in mind, you're going to do some checking before you start to work. If it's an even index, it's the principal root. If it's an odd index, it's whatever's in there. So let's take a look at what's going on here. Here I have the cube root of 27. So 27 is, the factors are 3 and 9, right? So 3 and 9 breaks down into 3 and 3. I'm looking for 3 of a kind. I got 3 of a kind, so the cube root of 27 is 3. And if you check that, 3 cubed does equal 27. Let's take a look at this. The cube root of 64. Whoops, that's not the right way. The 64 goes on the inside. So 64 is the same as 8 squared, right? Okay, that might help. 64, let's take 8 apart and see what happens. So we have cube root 2 times 2 times 2, that makes 8, right? And I need another 8. 2 times 2 times 2. Okay, I think I'm on to something here. I'm looking for three of a kind. So that's 1, 2, 3. Each of those is 2 squared, right? Or 4. If you're feeling a little uncomfortable with this, keep in mind that this is something you really need to practice to get the knack of. So don't just say, oh, I did the prep packet. Go make sure you do the homework and do the even numbers too if you need to. Let's go back and take a look at this. So I had the cube root of 64. Let's check our work. Is it true that 4 cubed equals 64? 4 times 4 is 16, and 16 times 4 equals 64. Now, up here, number 4, I see I have a negative here. And that makes me think, oh, I can stop. But no, actually, I don't have to because I have an odd number in the index. And remember, if I have an odd number, I can use any number. So here, again, we're going to take a look and see what's going on. So let's see. That's the same as 3 times 9, or negative 3 times 9, right? And 9 could be the same as, because it's positive, I could have negative 3 times negative 3. 1, 2, 3, 3, 3 of a kind. That's my principal root. And yes, it's going to be a negative. Now, here's another negative floating around, but luckily for us, it's on the outside because the index is even. Okay? And again, I'm going to just take a look at this, and I'm going to start with, I'm looking for 4 of a kind here. I have 9 times 9 makes 81, right? And what makes that would be 3 times 3 makes 9, right? And another 3 times 3 makes 9. And oh wait, I'm looking for 4 of a kind, and I have 1, 2, 3, 4 of a kind. So I have a 4 here and 4 of these here. That means 1 comes out. So there's your answer. Oh, but wait, it's supposed to be negative. So my answer is negative 3. Make sure you go back and review your problem before you run off and work on another one. Now here, let's take a look at this one. I'm going to do some analysis. First, I see I have an even index. Okay. It looks like a perfect square in there, so that's good. The only problem is that this is negative. And remember, if I have an even index and a negative there, it's not a real number. So you can just write not a real number. Okay, go ahead and stop and copy, and I'll see you in the next video.